So I'm sharing my screen. All right, so this is what we have for this week. We have to look at the concept of message passing and encapsulation. After that, we will have to look at the concept of inheritance. Okay, we have two major concepts to look at today: message passing and inheritance. All right. So you see that in computer science, we have a concept of what we call message passing, which is a form of communication that is mostly used in parallel computing, and it's also used in object-oriented programming. That is to say, if you have maybe two processes that needs to communicate with each other, you will see that they can communicate either by sending messages. Process 1 might just send a message to process 2, and process 2 will respond to the message. Okay, that concept of message passing is implemented in object-oriented programming. It means that what if you have an object, object 1 and object 2, if these two objects need to communicate with each other, what they need to do is to send a message. Okay, so object 1 can just send a message to object 2. Object 2 will respond to the message. And for this to happen, object 1 or both objects must provide a kind of an interface, or a kind of how do I put it? A door through which they can communicate. So it means each method or each object must indicate that, okay, I can only respond to this message. And for me to respond to this message, the message must be presented as thus. Okay, so that's why we're introducing the concept of message passing here, because this concept, which is generally a communication concept, or a communication means in parallel programming and also in inter-process communication. I think we will see this in our operating system course. So in operating system, we will see that processes communicate through message passing. So this same concept is used in object-oriented programming. Okay, so that's the major reason why we are introducing that concept. Okay, so we also have some web services. Okay, we also have some web services like SOAP that are also used, or that also use the concept of message passing. They also use the concept of message passing, which is more or less related to the datagram. You know, in a network, communication could be through datagram, like sending a datagram from one system to another. Okay, so but with the message passing, the advantage is that messages could be more, let me say, more larger than the packets that are used in or that circulates in datagram communication. All right. Okay, so now we are going to look at the influence of other programming, the influence on other programming models. That's the influence on measure of message passing. So we see that a message is simply a single means of control to an object. Okay, message is a single means of control to an object. That is to say, if you have an object A, that object will respond to a particular message. And for it to respond to that message, it must have that message or that method in him. It must have a particular method that corresponds to that message. Because when we say an object responds to a message, there must be some method in that object that is able to listen to that particular message. Okay. All right. So I don't know if you are getting the point. Is it too vague, or you are starting to capture? Is it fine?
Yes, okay, sir.
Okay. So what you need to know, like last time we understood the concept of object, which we said is a very critical concept in object-oriented programming. Okay. Now, when you have an object, we saw that what an object has its state and it has its methods or built-in functions. That's what makes an object. It has its states, which is some data, and then it has some methods through which you can interact with that object. Now, for you to interact with the object, you need to send a message to that object. And when you send the message to the object, you are sending the message to the particular method that the object is implemented in the object. Okay? You will not just send a message to the object like that, but you need to indicate to which of the object's methods you are sending the message. Because already the object will tell you that for me to understand a message, you must send a message with maybe integers, 2 integers, or 1 integer, or an integer and a float, or an integer and a string. This is a way of calling an object. Okay, so we saw that the notion of object is critical in object-oriented programming. Even though some researchers also saw that the concept of message passing is also very important, and that it is even more important than the objects in object-oriented programming. Okay, so as much as you see the concept of object very important in object-oriented programming, so is the concept of message passing, because that is the means through which you or objects communicate with each other. Okay, objects communicate through each other through message passing. Okay, so I believe it is fine at this level. It should be fine. We take an example of maybe the bicycle object that we saw the last time. We saw that there was a method in it that was maybe change the gear of the bicycle. Okay, change the gear of the bicycle was a method that was taking into parameter an integer for the new gear that you want to change. Okay, the bicycle was defined with the first gear, which was maybe 1 or 0, and then it implements a method, or it provides a method called change gear, through which you can interact with that object, with the bicycle, in order to change its gear. So what happens is that the bicycle will now provide what? Will now provide this method to the outside or to other objects. And then other objects will do what? They will call this method and send a message. They will send messages to this change gear object. And how would the message they send look like? The message they send to the object must be, or must contain, the value of the gear that they want to change. Okay, it must contain the new gear value that they want to change. It is the same like we saw the method to increase the speed of the bicycle. The method is there, and what does it do? It takes some value, an integer, and it adds it to the initial speed that the bicycle had. For example, if the bicycle was running at the speed of 1 meters per second, and you call the change speed method, and you add another 1, the bicycle should now be running at 2 meters per second. Okay, now When you want to use this method to change the speed of the bicycle, it is a message that you need to pass to that bicycle. And you pass this message because the bicycle itself has provided you a method that is able to respond to this, or that enables the bicycle to respond to those messages of changing gear or changing speed. Okay. So each time you will build your objects, you will need to know what are the states of that object. When you understand the states of the object, what are the methods that the object that you are going to associate with this object? And when you have the method, you will now need to identify if there is another object that needs to interact with your object. It needs to send a message to your object. What is the format of the message that it needs to send? What is the content of the message? Okay, it's just like the same like you have application programming APIs, that maybe you have third-party applications. You have your application that is interacting with maybe Orange or MTN platform to use the MTN messaging service. What do? In your application? You will need to build a function. You will need to build a function that will send a message. Okay, and your message is going to be based on what? It is going to be based on the method that, or the interface that MTN is providing to you. MTN can provide an API to you that, or an interface that permits you to, that will only collect the telephone number. Okay, just the telephone number. So it means that the message that you'll be sending to that MTN object will just be a telephone number. Each time you want to send an SMS, you will just send a telephone number. Or it could be that you are going to send a telephone number and the content of the message of the SMS that you want to send. So it means the MTN application will provide to you an interface. Which is kind of a method. And that method is responding only to messages that are telephone number and SMS content. So each time you will call this method, you will be able to use the interface or the object implemented in the MTN service. Okay, it's the same logic. So now we have the second concept, which is that of encapsulation. So we see that objects actually combine data and operations on the data. When we say data, we are talking about the state of the object, and the operations are the methods, okay? And an object combines this data and operations in a single unit, okay? And this is what is called encapsulation. Meaning that what? Meaning you have an object which already has, which is bundled, or in which is encapsulated some data and then some methods. Okay, so that is basically the concept of encapsulation in object-oriented programming. The fact that an object has data and some methods or some operations on the object that are built in one, that appear as a single unit. Okay. So what you do is that you first of all identify the object. For example, if you are building your application like we saw, maybe an application to manage a school management system. The first thing that you need to do is that you need to identify the different objects that are intervening in that application. You will have students, you will have lectures, you will have courses, you will have lecturers, you will have notes, you will have halls. So you will identify all the objects that are concerned. And then you will identify for each object, you will identify the relevant data. The data or the characteristics of students, you will identify them. They might not be the same as the characteristics of lecturer. They will not be the same as the characteristics of a course. So you will identify the different characteristics of these objects after identifying the objects. And then you will need to do what? You will need now to identify the methods or the operations that will be needed to manipulate these objects. Okay, the same methods that you will use to manipulate student object is not the same that you will use to manipulate lecturer or that you will use to manipulate courses. Okay, so each object has its specific methods that you will implement. Okay, for example, if you have a bicycle object, a bicycle will not respond to the same, will not have the same methods like maybe how would I call it? A horse. A horse is also used for movement, but the bicycle might not have the same methods like the horse. Okay, and they might not respond to the same messages the same way. Okay, so when you have objects of the same type or of the same class, you will see them responding to the same messages in the same way. Okay, so the concept of encapsulation is simply trying to make you understand that you have an object, and in the object you have both the data and you have the operations on those data. So that is encapsulation. Okay, you see that older programming languages did not actually implement this encapsulation, and it resulted in a lot of difficulties. Okay, it resulted in a lot of difficulties because with the encapsulation, you are able to control what is happening to your object. You are able to control what any external system can do with your object, because the object will only respond to the message that has been exposed. Okay, and then that was not the case with earlier programming languages, and which led to the situation where variables or contents of objects could be unexpectedly changed. Okay, could be reused without you really mastering what is happening. And then you had some kind of code that was not easy to understand because the program codes were so mixed up. But with the object-oriented, you see that you have modules and that are objects that are easily separated and can facilitate troubleshooting. It can facilitate troubleshooting. It can facilitate the understanding of your code. Okay. So we see that encapsulation is also a very critical principle or important principle in object-oriented programming. Okay. Encapsulation is an important principle in object-oriented programming. And we have seen the advantages of encapsulation. You are able to have control on what is happening on your objects, and you will see that your code is also well organized. Your code is easily understood. You can easily maintain your code. You can easily troubleshoot. If there are errors in your program, you can easily troubleshoot object by object. So that is the advantage of encapsulation. Okay, so we also have what we call data hiding. Data hiding is also another concept that you have in object-oriented. Okay, and data hiding is simply a situation where you have an object that shields itself, that protects some of its internal variables from external access. It hides it. So it means objects will not need to, you don't need to understand what is happening within an object. When you call maybe an API from MTN, you have signed a contract with MTN and you want to use their SMS service to send SMSs. When you do your payment, your registration on your student platform, you use mobile money, right? You use MTN mobile money, not so?
So, sir.
Yeah, you use MTN mobile money. So you see that there is an API. There's an API that, or there is an object in that MTN mobile money, which is in the MTN system. MTN does not need to give you all its access to all its objects. MTN gives you access just to the essential object, which is the object that is responsible for sending that SMS. And when MTN gives it to your application, it gives what? It indicates the type of message that you can send, that is going to receive. If you are sending, if you want to communicate with that, with the method, with some content that it does not understand, there is no way you are going to, the object is going to respond or understand your message. So that is an example of data hiding. It means you don't need to understand what is, MTN does not need to tell you what is happening inside their system. But all you need from them is to send the appropriate message to the appropriate object, and then they will do the job for you. You don't need to understand what is happening in their application, and they do not expose all their variables. They do not give all their variables and all their objects to you, to the external access. Okay, so this concept also is important in object-oriented programming. Okay, so that's why we say methods can also be completely hidden from external use. You can have an object that the method is there for the internal use of the object. This method is not given to external, to any external object. The communication, this method is used maybe by other internal objects, other internal objects in the same application, but external objects cannot access this method. So also important. So encapsulation is a concept for hiding the implementation details of a class and allowing access to the class through a public interface. So there will always be a particular public interface that will be given to other parties that want to access the functions in the class. So I believe you now understand, from our last lectures, you understood the meaning or the difference between the class and an object. Can somebody tell us? Can somebody remind us the difference between a class and an object? Evani, can you tell us? Clinton, we are just 4 of us in the class. 3
Yes,
students and 1 lecturer. So can you, somebody should quickly remind us about objects and classes. What do you understand in relation to objects and classes? Just tell us what you understand about objects, what you understand about classes. Like the relationship between objects and classes in object-oriented programming.
So for a class is like a template or a container for objects, and objects are members or instances of a class.
Okay, yes. Any other thing?
Yes, objects have a state and methods. Then
Yes, I'm listening.
so I can complete.
Yeah, but what you said is right, okay? What you said is right. That is to say that you cannot have an object when you don't have a class. You first of all define a class. And in fact, a class is, from the real sense of it, it is a class. It means what? You are going to identify a class that you will say, okay, I have students as a class. Students is a class. Lectures is a class. Lecturers is a class. Now, what are you going to do? You have student one, you have Clinton, you have Evelyn, you have Blaze. These are objects, these are students, not so. And you
Yes, sir.
want to estimate that all of them have the same behavior. They belong to the same class, which is student, but they are different objects. Why are they different objects? Because you people do not have the same internal state. Although you have the same variables, but you do not have the same internal state. That is to say that when you want to look at Clinton, the date of birth of Clinton is different from Evani's date of birth. Clinton's name is different from Evani's name. Clinton's, I don't know. You see, you people do not have the same internal state. You are the same, you belong to the same class students, but you do not have the same internal state. So that is what is differentiating you, okay? It means that you can create as many objects as there are students. And each time you will create it from the class that is already existing, which is student. All of those objects will be student. Same as lecturers. When you know that, okay, you identify a group of persons that are lecturers, you then say, okay, each time there's a new lecturer, you will create him as a lecturer. And you want to believe that all these lecturers have the same attitude or the same internal state. Sorry, the same, let me say the same variables, the same characteristics. But now you will see that these lecturers also, each lecturer object also has its specificities. Okay, maybe you have Dr. Saibini and myself. Dr. Saibini teaches this course, I teach this other course. Dr. Saibini, you see, because lecturer should have a course that they teach. Maybe he teaches course A, I teach course B. You have maybe his name is this, my name is that. So we are all lecturers, but we have different, our states are different. And this makes us separate objects or individual objects of the same class of lecturers. Okay. So that concept should be very clear in your mind. And once you understand this concept, you are good to go with object-oriented programming. Okay. So we will see this concept of Java beans. Okay, this Java beans concept. I think I will give you one tutorial where you will see where you can start from your database table. You start from a database. I believe last year we had a course on database and everybody was able to create a database with at least 3 tables and populate this database and write queries on this database. We did that last year, right?
Yes, sir.
Yes, we did it. So you will now see how you can be able to interact with this object, with these databases. So what you see is that in your database, the things you identify as tables will now be seen as what? As classes, okay? You had a table, maybe there was a table student. So what you will do is that in Java, you have what you call Java beans, that you can call these entities from your database and you call them and they become classes automatically. You create them as classes. And then all the methods that you have, all the attributes that are in this method, you are going to create some default methods, what we call the get and the set methods. Okay, the get and the set methods will permit you to be able to do what? To set for each attribute, maybe a student name, you will have set student name that permits you to change the student name. Get will permit you to display a student name. Okay, we will see this. We will see this as subsequently. All right. All right. So here they try to give you an example, a small example. We have a class, a public class employee. Okay, you have a public class employee, and then you will see the variables that you have in this public class. You have the variable salary, which is a private float. salary of this employee. And then you have the method get salary. Get salary. And then this method is returning what? Public float get salary. It is returning salary. Remember, each time you define your method and you put the return value, you must indicate return something. But if you have a void, you don't need to have a return value. If you say public int get salary, it must return some integer, or it must return a value. Okay. Then you have another method, public void set salary, which is taking into parameter as a salary, and it is saying that this salary should be equal to salary. Okay. So look at what is happening. It is just an example of the get and the set method. They have defined an employee class, and on the employee class, by default, we have the get method that permits to get, to receive, or to display the salary of some student or of some employee object. And we have the set salary object that will permit you to do what? To insert or to affect some salary to an employee object. Okay, so what you will do technically at the back end, what will be happening is that on your database, you have the table employee, you have the attribute salary for employee. So each time you will want to input the salary of the employee, you are going to just call this method. You just call the set salary method and you put some value, maybe 10,000 to be the salary of the employee. God forbid, 10,000 is too low. Let's say 10 million.
$10,000. $10,000.
Yes, $10,000. So let's say maybe 1 million. Let me call something realistic. 1 million as a salary of the employee. Then you just call this set method. If you want to see the salary of the employee Clinton, for example, you just call the object employee Clinton and you call this get salary. So you will just do something like, let me try to represent. You will just do something like, sorry, it is freezing. Okay, let me try to represent for us to understand. So now we have the objects, you have the class employee. You can say you want to create an object of type employee. You say employee E or E1 equals new employee. We saw that this is how we create objects, right? We create objects of the class. So when I do this, I've created an object of type employee that I call E1 because this is existing. I can then do E1 dot set salary.